Okay, we're doing number 27 from 7.5. It says a cylindrical gasoline tank, 3 feet in diameter and 4 feet long, is carried in the back of a truck and is used to fuel tractors. I try to draw a picture of it here, not drawn to scale though. The axis of the tank is horizontal. The opening on the tractor tank is 5 feet above the top of the tank in the truck. Find the work done in pumping the entire contents of the fuel tank into the tractor. Okay, so the idea here is we have fuel being pumped from the lower tank to the higher tank, how much work is being done to completely empty the lower tank. So what's important to look at here is how big is a layer of gasoline, and we can call the thickness of that, as we typically do with our layers, we'll call that dy. And we know that the width is 4 feet. So what's this other dimension going to be? Well, that's a circle. And so think about a circle. And if it's helpful, we can, I think it's most helpful to center this at the origin. And if the diameter is 3 feet, the radius is half of that, so 3 halves, or 1.5. So the formula is x squared plus y squared equals 3 halves squared. So that means x squared plus y squared equals 9/4. And since we're doing a vertical change here, we'll solve for x. X squared equals 9/4 minus y squared. And x equals the square root of 9/4 minus y squared. Now, to think about this, this only gives us the stuff on the right side of the y-axis, so the width is going to be double this. And that's how we get this to be 2 times the square root of 9/4 minus y squared. That's where that comes from. Okay, so our volume of a layer, call that V, volume is length times width times height, and that's going to be 4 times 2 times the square root of 9/4 minus y squared dy. Okay. Oh, I should call it delta y. I'm sorry. We call it dy when we get to the integral. And the weight, they tell us the weight of gasoline is 42 pounds per cubic foot. These dimensions are in cubic feet, so that's going to be 42 times 4 times 2 is 8 times the square root of 9/4 minus y squared delta y. So now let's talk about the distance it travels. The distance the fuel travels, this is kind of a tricky part. It's kind of hard to explain too in this setting. So if you think about it, if it were to go from the top of the tractor tank to the middle of this tank, it's going to go 5 feet plus the 3 halves a foot. If it's going to go from the top of the tank to the top of the tank, that's just 5 feet. If it goes top of the tank to the bottom of the other tank, that's 8 feet. And so the formula we come up with is, so what's going to vary is the height on the circular tank, and that's going to vary as y. So the most it becomes is 3 halves, and the least it becomes is negative 3 halves. So if we do 5 plus the 3 halves and then minus y, that's going to give us 13 halves minus y for the height or distance it travels. So on the one end, if y is 0, it's at the middle of the tank. If y is 3 halves at the top, so that's a distance of 5, And if y is negative 3 halves, it gives us 16 halves, which is 8. So the work done is going to be the integral, I'm going to go to decimal format here, negative 1.5 to 1.5 of 42 times 8 times the square root of 9/4 minus y squared. So that's the weight times the distance now. The distance is 13 halves minus y, and the delta y becomes dy. So if I start doing some multiplication, 42 times 8 is going to be 336 times, and now I'm just going to write it like this. Integral from negative 1.5 to 1.5 of the square root of 9/4 minus y squared times 13 halves minus y squared, no, just minus y, excuse me, dy. So if I split up that integral, the difference of 13 halves minus y, I'd have the integral from negative 1.5 to 1.5. I forgot my 336. 336.
Jeez. No one will get that reference yet.
And then I'd have that 13 halves times the square root of 9/4 minus y squared dy. And then minus 336, integral from negative 1.5 to 1.5 of the square root of 9/4 minus y squared times y dy. So the second part of this is an odd function. And since we're going from negative 1.5 to 1.5, it cancels out. So this is odd function. And we have a symmetrical, with respect to the origin, limits. So that means it equals 0. So what we're left with is this other part here. 336 times 13 halves, integral from negative 1.5 to 1.5 of the square root of 9/4 minus y squared dy. So I actually looked this up in the appendices. There's tables of integrals. I used one of those. I don't know that we covered this last semester or not. I just don't recall. But that's where I got this next formula. And it's an arcsine formula. It may have been that we covered this in doing arcsines. I think we did in like 7.7 integrals. So this becomes 336 times 13 halves times, and the formula goes 1/2 times y times the square root of 9/4 minus y squared plus 9/4 arcsine of y over 3/2. We do that from negative 1.5 to 1.5, which again 1.5 is 3/2. So that's going to give us 336 times 13 halves times 1/2. Now we plug in those limits of integration, and like I said, it might be easier to see that in terms of 1.5 is 3/2 square root of 9/4 minus, what's 3/2 squared? Oh, it's 9/4. That's 0. Plus 9/4 arcsine of 3/2 over 3/2 minus negative 3/2 times the square root of 9/4 minus 9/4 plus 9/4 arcsine negative 3/2 over 3/2. Well, in each case, that radical part is 0. So we have 336 times 13 halves times 1 half times, and we have 9/4. And notice this is arc sine of 3 halves over 3 halves. That's just 1. Arc sine of 1 is pi over 2 minus the 9/4. Arc sine of negative 3 halves over 3 halves is negative 1, so that's going to be negative pi over 2. So it's 336 times 13 over 2 times 1 half times 9/4 pi. Because you have pi over 2 minus negative pi over 2. And this gives us 2457 pi foot-pounds. Woo, that was a fun one. Okay, there you go.